Hi student, now we are going to see about basic operational concept in computer organization and architecture. In this video, I will explain how a computer executes the instruction and process data and coordinates the activity between the CPU, memory and input-output devices. This may introduce the fundamental mechanism that make a computer functions like fetching, decoding, executing, and storing the instructions. Storing and executing program. In a computer system, the programs are stored in a memory as a list of instructions. The CPU fetches each instruction and decode it and execute the specified operation and store the result. For example, here is the instruction add location A or none. The processor fetches the instruction and retrieves the operand from memory location A and add it to register R0. Then finally store the result in a R0. That means write back the result in a R0. This describes the fetch execute cycle and central process that enable the computer to run a program. Processor component. Here, commonly we know the processor is a brain of the computer and it consists of several important components like instruction register, program counter, general purpose register, memory address register, and ALU. The instruction register. The instruction register holds the data, holds the instruction being executed. Program counter keep tracks keeps track of the next instruction's address. General purpose register stores the temporary data. Memory address register holds the data to be accessed in memory, while the memory data register holds the data itself. ALU performs an actual computational operations like addition, division, subtraction, multiplication, etc. and logical operation like and or not, and etc. In this, each component plays a specific role in controlling the flow of data and instruction between the CPU and memory. Here is the diagram that shows a connection between the processor and the main memory. Program execution step. The program execution follows a four main steps. First step is fetch, next is decode, third is execute, and fourth is store. First step, fetch. The program counter sends the address to the memory address register and instruction is fetched into the instruction register. Decode. The control unit interrupts the instruction. Execute. The ALU performs the operations. Store. The result is write back to the memory or a register. Finally, the program counter increment to the point to next instruction. This may illustrate instruction cycle that happens millions of times per second in a modern CPUs. Interrupts and exception handling. Interrupts allows the processor to temporarily pause a running program to service an urgent request such as input from a keyboard or disk operation. When an interrupt occurs, the CPU saves its current state and executes an interrupt service routine and then restore the saved state to resume a normal execution. That means the interrupt improve the system efficiency by enabling the multitasking and handling the urgent events without stopping the main program permanently. Memory and processor connection. The processor communicates with the memory through buses or control circuits. The registers like MAR, MTR, PC, and IR ensure the data transfer between the memory and the CPU. The ALU and control unit manage the actual computational and signal coordination that shows how the data and control signals flow inside the CPU and the memory. And understanding the concept of hardware communication. Here is the example. Let's revisit the instruction add location A or not. First, the instruction is fetched from a memory using the program counter. Next, the operand at memory address location A is fetched. Then ALU performs the addition of the operand and R0. Finally, the result is stored back in a R0 and the program counter increment to the next instruction. This reinforces the instruction execution process and a complete example of how a CPU processes one instruction cycle. Thank you.